Hi everybody, this is a fairly quick video. We're going to focus just on solving equations where we have equations on both sides of the equal sign. So the left and the right side have a variable, okay? So the steps really for solving aren't any different than they would be for a normal equation. Um, the only extra step we're going to have is we're going to do something called collecting the variables to one side of our equation. So let's just jump into an example. All right, so here's our first equation. You'll notice if we split this into two sides, we have an m on the left side and the right side of our equation. Now, we can't combine these. We can't make it a 3m, and even if we did, we wouldn't know which side it would go on. That's not what we want to do. We want to collect the m's to either the left side or the right side. It doesn't matter which side they go to. I typically try to make it so that I'm left with a positive number, a positive coefficient in front of my variable. So for example, if I subtracted 2m from both sides, that's going to make me get a negative number for m, the coefficient of m on the left side. So what I'm going to do instead is to collect my variable to one side, I'm going to just subtract m from both sides. Okay, and remember that this is really a 1m that we're subtracting. So if I do m minus m, there's not an m left on the left side anymore, which is what we're trying to do here. We need to get our variable to one side so that we can solve for it. So now on the left side of our equation, all we have is a negative 2. We have our equal sign, we have a 6, and 2m minus 1m leaves us with just m, or 1m. Okay, so now it looks just like the equations we've been working with. I'm trying to get m by itself, so now I need to subtract 6 from each side. These will cancel, and we're going to be left with negative 8 is equal to m. So that step where we got m to just one side of the equation is called collecting the variable. We just get it to one side. It can be the left side, the right side. It doesn't matter as long as the variable is just on one side of our equation. All right, next example. Okay, very similar. Let's split it. And let's decide which side we want to move the x's to. So let's add 8x to each side. If I add 8x here, it's going to cancel. If I add 8x here, it's going to leave us with a positive 1x, which is just x. So now we have x plus 5 equals negative 3. Try to get x by itself. So we need to subtract 5 over here, which means we have to do it to the right side to keep it balanced, and we get our final answer. X is equal to negative 8. Okay, feel free to pause before each of these problems your own, and then you can check your answer. All right, our next equation here. Split it. Let's collect our variables, k, to the left side. So we're going to subtract 2k. So it cancels here. Also subtract 2k from this side. So now we have 4k minus 2k is 2k, plus 2 equals 16, and we're trying to get k by itself. So remember, we undo addition subtraction first, so we're going to get rid of that plus 2 by subtracting 2. Okay, now we have 2k equals 14. To cancel out the 2 that's multiplying k, we have to divide by 2. And we end up with k equals 7. Okay, our next one here. Now, this one's a little different because on the left side, we can combine n and 4n to make 5n, which leaves us with 5n is equal to 7 plus 4n. So we have to combine the ends on the left side first before we can collect our ends to just one side of the equation. So now that we've done that, let's go ahead and cancel out this 4n by subtracting 4n. 5n minus 4n leaves us with 1n, or just n, equal to 7. All right, our next one, same kind of thing. We have some combining that we can do on the left side of our equation before we collect our variables to one side. So let's go ahead and do this. This will give us negative 4m plus 7 equal to 7m minus 15. Now, if I subtracted 7m from each side, I'm going to end up with a negative coefficient. So instead, I'm going to cancel this minus 4m by adding 4m to each side. That's going to keep the coefficient positive. So now we have 7 is equal to 11m minus 15. We undo addition and subtraction first, so we're going to add 15. That leaves us with 22 equals 11m. We'll divide both sides by 11. And we get our final answer. 2 is equal to m. So I can see it starts getting a little trickier here. All right, next. We don't have any combining to do on the left side, but on the right side, we can combine these two terms. So let's go ahead and do that. We have 5 minus 3n, and if we combine terms, we'll get negative 2n. Now, I want to keep the coefficient positive in front of n if possible. So to do that, I'm going to cancel out this minus 3n by adding 3n to both sides. Now, if I do that, that makes it just 5 on the left side, and on the right side, negative 2n plus 3n leaves me with positive 1n, which is just n. Now, this is the first equation we've seen today where we have some distributing we need to do. So remember, we want to split our equation into two sides first, and I told you guys anytime you have a number in front of parentheses, we want to distribute. So I'll draw my arrows here. Let's just rewrite the left side. I'm not doing anything with the 7 here yet. We're going to just distribute the 8. So if I distribute 8 to 7r, okay, remember we're multiplying, we're going to get 56r, and 8 times a positive 1 gives us plus 8. Now, if you look on the right side, we have some combining that we can do with our constants. So let's rewrite that again. Negative 6r plus 15 equals 56r plus 15. Okay, now we want to keep our variable to one side. So I want to keep it positive. Let's add 6r. So it cancels here. Add it over here. So now we have 15 is equal to 62r plus 15. We undo addition and subtraction first. So we want to subtract 15. So it cancels. Something interesting is going to happen. When we subtract 15 on the left side, we end up with just 0 is equal to 62r. And remember, if you have 0 in your equation, that's not necessarily a problem. Okay, we can keep going here. We have 62 times r. So we undo that by dividing by 62. Okay, and 0 divided by 62 is just 0. So our answer is r is equal to 0. All right, another example with distributing. So let's split our sides. And let's distribute. Now, when we distribute, we're going to carry that minus, that negative with us. Okay, so when we multiply, we're going to be multiplying by a negative 2. The 2a that's in front is just going to drop down. So if I distribute negative 2 to negative 3a, remember we're multiplying, that's going to become a positive 6a. Negative 2 times positive 6 is minus 12. Okay, so there's our new left side. The right side, nothing has changed. Now, on the left side, we can also combine these two terms. So let's rewrite that. Now we have 8a minus 12 is equal to 6a plus 4. And now we can go ahead and collect our variable to one side. So let's subtract 6a to cancel it here. Subtract 6a here. 8a minus 6a leaves us with 2a. We drop our minus 12. That's equal to 4. So now we just undo addition and subtraction first. So we're going to cancel out minus 12 by adding 12. So now we have 2a equals 16. We can undo this multiplication by dividing. And our final answer here would be a is equal to 8. Now these last two examples are going to be something slightly different. Okay, just right off the bat, you can see that we have a lot of terms here on each side. So we have some combining that we can do to get things started. On the left side, we have a 10x and 2x. They combine to make 12x. Minus 4 just drops. There's nothing for it to combine with on the left side. On the right side, we have a 15x, a minus 3x that combine to make 12x. We have a positive 2 and a minus 6 that give us minus 4. Now, I want you to look at the left side and the right side of the equation here. Hopefully you notice that each side is exactly the same. So what that means is, no matter what number we plug in for x, this equation is always going to be true because each side of the equation is exactly the same. Now, here's how we show that using algebra. Let's go ahead and just collect our variable to one side like we normally would. Okay, let's cancel this 12x by subtracting 12x. Okay, let's cancel. What happens is when we subtract 12x from the other side, it also cancels. So what we have here is we have an equation with no variables and just numbers. Okay, negative 4 equals negative 4. And I want you to ask yourself, is that true or false? If the statement is true, like this one is, that means that there is an infinite number of solutions. Many times you'll hear me refer to this as all real numbers. Which is given by the symbol here. Let's look at another example. Okay, very similar. So let's split it, combine, and see what we have. On the left side, we have two constants that can combine. So we have a 2x plus 5. On the left side, on the right side, we have a 3x and a negative x that combine to make and a plus 7 that's left over. Now I want you to look at these two equations again. They both have 2x, but the left side has a plus 5, the right side has a plus 7. So if they both have 2x, the right side is always going to be bigger than the left side by 2. Okay, well, if that's the case, then they're never going to be equal and there's not going to be a solution. But let's see how we could show this with algebra. Let's collect our variables. Okay, let's cancel 2x on this side by subtracting. And let's do it on the left as well. Okay, just like the last example, this 2x cancels as well, and we're left with an equation that just has numbers, no variables. Now, 5 does not equal 7. Okay, this is not true. Okay, this is false. 5 is not equal to 7. So when that's the case, your answer is that this equation has no solution. All right, make sure you rewatch it, ask any questions, and have a great day.